In today's lesson, we are talking about the sine law, all right? So a big preface to these laws that we're about to encounter is the reason the sine law in this lesson and in the next lesson cosine law exist is when we are asked to solve different parts of a triangle, so angles or side lengths, for triangles that are not right angles, okay? So I'm just going to put a little note right here on the side. So you have two camps that you can be in, right? You have triangles that are right, like right angles, and then you have non-right angles, okay? So today's lesson is about non-right angles. When they're right angles, you use sine, cos, and tan, right? Those ratios. When you're non-right, you deal with the sine law, which is today's lesson. And then tomorrow's lesson, we will talk about the cosine law, right? So that's just the easiest way to think about it. If I give you a triangle that is not right, as in today's lessons, you are going to approach the problem using either sine law or cosine law based off your given information, okay? So what the sine law is this right here. And I will go into more detail about that now. I just don't want to confuse you so much. All right. So let's go right into an example, and then you'll see where these formulas come from. So in example 1, in triangle ABC, angle B is 48 degrees, so this angle here. Angle C is 25 degrees, so that angle there. And side length A is 36 centimeters. Find measurement of B and C. Oh, and actually, let me just jump right back up. Just so you understand like notation on a triangle, like what these little letters mean here. That's what this example right here is kind of just showing you. So in math, we give big letters, the capitals, as the vertex, and the side length that is opposite from it gets the lowercase of that letter. So this would be A. And this side length right over here, this would be little b. And then this one right here would be little c, okay? So that's why this right here, A, is 36 centimeters. So we are looking for measurements of B, and we are looking for measurements of C. All right, well, you can see that none of these angles here are 90 degrees. And actually, how do we find this angle to prove that? Well, this angle right here is 180 minus 48 degrees minus 25 degrees, because the sum of all angles in a triangle need to be 180. So if I take away the two that are given for me, so if I do this on my calculator, I find that that angle up top there, that's 107 degrees, okay? So this is 107 degrees. So none of these angles are right angles. So if I'm looking for these two side lengths, C and B, I cannot use my basic trigonometry. But the sine law says if you know an angle and an opposite side length, okay? So in this case right here, I have an angle, this 107, and I have its opposite side length. I can take that combination, okay? So I can take the side length, the opposite key thing, side length, and divide it by its angle, and I can set that equal to any of the other combos. When I say combos, an angle and its opposite side length. That's what the sine ratio is. So because I have the ratio A over sine A, I know what this is. This is 36 centimeters, the measurement given, and we just found what big A was. It was 107. So I know what this ratio of side length to angle is. I can set that equal to any combination of angle and opposite side lengths. So let's do B first. I have the angle 48, but I don't know the opposite side length. So I don't know what b is equal to, but I can divide that by sine 48 degrees. And notice how this is our only unknown. It's the only thing that we don't know in this equation that we have created. And in math, if you only have one unknown, you can solve it, okay? So this whole thing only works, all right? The whole sine law only works if you have this, okay? Where you have some combination of a side length or an angle and its opposite side length. You need that, okay? So when you're approaching with sine law, that's your goal. Find some angle and its opposite side length. Once you do that, just fill in the blanks and find the others. So we are going to solve this for b. So in order to get b on its own, we need to multiply both sides by sine 48 degrees, okay? So that means this and this cancel, and we need to put a sine 48 degrees over here. So right now, this is saying, okay, take 36, right? So sine 48 degrees. Take 36, I'll write in purple, 36, divided by sine 107, and then multiply it by sine 48 to get b. So we'll do that in steps. So 36 divided by sine 107. This bracket right here becomes 37.64. And then sine 48, this bracket here, becomes 0.74. Take those, multiply them together, so times 37.64. You get b is equal to 27.97 centimeters. That's our units. So this side length right here is 27.97 centimeters. Do the same thing for side length C. Again, you use your ratio, because just like you can set this ratio equal to this one, you can also set it equal to the other one, okay? They're all equal. It's a constant, all right? The sine law says that a side length divided by its opposite angle is equal to any other side length divided by its opposite angle. So that means we can take, once again, our known ratio of side length and angle, so sine A, and we can set that equal to C over sine C, where, I'll put this one in red, where this is our only unknown, because if we fill in what we have the sine 36 over sine 107, and we have C, we don't have C, but we have angle C, which is 25. So isolate for C, so multiply both sides by sine 25 degrees. So multiply this by sine 25 degrees. All right, so you get these cancel. You get sine 25 degrees multiplying 36 over sine 107. And that gives you side length C. So it's just a calculator problem again. So sine 25, all right, this gives us, this first bracket, 0.42. And then 36 divided by sine 107, we get 37.64, which we already calculated before, so I could have just saved myself that step. And multiply both of those together, we get a C value of 15.8 centimeters. Okay, so this side length right here is equal to 15.81 centimeters. There we go. So we'll just see it in more practice, okay? And by the way, these two formulas, the reason it's like or here is because like these are identical to each other. It's just like depending on which one you're looking for. So in this case, I chose to use these ones because the unknowns I was looking for in the first problem were the side lengths. But let's say the unknown I'm looking for is the angle. It's just easier, okay? It's not wrong to use the other one, but it's just easier if you use this side, where the unknown is what's up top, okay? Just makes the math a little easier. So in an acute triangle ABC, angle B is 35, side length A is 64, side length B is 42. Find the measure of angle A. Okay, so because I'm looking for angle A, I'm going to opt to using this side of the sine ratio, okay? So like these combinations right here. So let's draw out our picture. We have some triangle ABC, A, B, and C, where this is A, doesn't matter where you put them. And as long as you are filling the blanks accordingly, okay? So side angle B, this is 35 degrees. Side length A, so the thing opposite A, that means this right here would have to be a little a. This is 64. Side length B, so that means this is opposite of angle B, so that's little b, is 42. Find the measure of angle A. So we are looking for this angle right here, okay? So what we ultimately need to do is we are trying to find this angle A that I put in purple, all right? And we have to set up our ratio. We have its opposite, 64, but we need to set it equal to something we know, okay? A ratio that 100% is true. So what combination of angle and opposite side length do we have? Well, we have this combo right here. We have the 35 and its opposite side length. So we can set what we're looking for equal to sine B, all right, over little b. So that's sine A, which we're looking for, over 64. And we know sine B, which is sine 35. And we divide that by its side length, 42. So angle A is our only unknown here. So first step is multiply both sides by 64. Multiply this by 64 because that means this 64 and this 64 cancel. And you get sine A is equal to all of this. So that is math just going sine 35 equals dividing that by 42 and then multiplying that by 64. You get 0.874. But again, we don't want what sine A is. We need the angle. So that means you need to take the sine inverse of both sides. And like I said in the previous lesson, the proper notation is you take the inverse. And you don't have to do this whole like showing both sides, okay? That's not proper math. You just take the inverse of one side and know that that's how you get rid of what's on this side. So sine inverse 0.874. That's going to give us our angle. So on my calculator, I hit shift, sine, and then I type in the number that I see there. And that gives me an angle of 60 point, and it didn't specify how many decimals, so just one decimal is enough for an angle. So 60.9 degrees. So this angle right here is 60.9 degrees. Okay, there we go. So again, these problems find a ratio that you have. So in this problem, we knew what this is, and that means we were able to then set it equal to the one we were looking for. So solve for the triangle. Okay, solving the triangle means find the value of the unknown sides and unknown angles. Everything needs to be filled in, okay? So we need all of these angles here, and you need all of the side lengths. That's what solving a triangle means. So let's fill in the piece of information that's given to us. We have C, angle C being 34, so that means this one right here is 34 degrees. We have, oh, and I guess this notation's off. This is really D over here, okay? So D is 75. That makes this side length given to us right here, little d. So we can see that we have a combo. We have an angle and its opposite side length. So the ratio that we are going to be using to set all of our unknowns equal to, all right, the one we know that sine d over d. We have this ratio, okay? So let's solve for everything else. So let's start with angle or C, because you can see we have 34 degrees, and in looking at C, we don't have this side right here. So let's get that little c. So we take what we know our sine d over d, and we set that equal to, and actually because I'm looking for a side length, I'm going to use the other one, d over sine d. It doesn't matter as long as you are consistent. So because I'm putting my ratio with the side length up top, that means you set it equal to the other one with its side length up top, okay? All right, fill in the blanks. So we have a little d, that is 21.2. We have angle d, so that's sine 75. And we set that equal to little c, which we don't know, and we divide that by sine angle c, which is 34 degrees. So we are isolating for little c, so that means multiply both sides by sine 34 degrees. So then these cancel, and this side needs to have a sine 34. So you have sine 34 degrees multiplying 21.2 all over sine 75, and that's all equal to c. So again, it's just a calculator problem now. So you're taking 21.2, dividing that by sine 75, and then I'm multiplying that by sine 34. So if you did that in your calculator, and you should try to do that in your calculator, okay? Not just simply follow along with this lesson, because practice using your calculator and making sure you are getting this, 12.27, and the units that we're dealing with are centimeters. Okay, actually I'm going to shrink this because I'm going to run out of room on this problem, because I still need to get all my other unknowns. All right, so we don't know what little e is. We also don't know what this angle is. So if you think about setting up this problem, if I take my known ratio, d over sine d, and I try and set that equal to little e over sine e, well, I don't know this, and I don't know this. So there is no way mathematically for me to solve this. But you can use the other property of a triangle that says all of these angles inside the triangle need to add up to 180. So then to solve for angle E is really just 180, what all they need to equal to, take away what the other angles are. So 34 degrees minus 75 degrees. And if you do that, so 180 minus 34 minus 75, you'll get angle E to be 71 degrees. So this, I should have done purple, but this should be 71 degrees. So now you know what this is, and you can use this ratio, okay? So let's do it. We have d over little sine d, so 21.2 over sine 75 degrees. We set that equal to E, which we don't know. That's what we're looking for. But we now have angle E, which is 71 degrees. So isolate for this E right here. Multiply both sides by sine 71 degrees. So multiply this by sine 71 degrees. So you get sine 71 multiplying 21.2 over sine 75. That's all going to be equal to E, because these cancel. Once again, plug it into your calculator. So it's 21.2, divide that by sine 75, multiply that by sine 71. So I'll just write this out just so you can actually see it. So this would be sine 71. I did this for bracket first on my calculator, so I got 21.94. And now when I go 21.94 times sine 71, that's when I get my E to be equal to 20.75 centimeters. And there we go. So there is all of the unknowns. So we had to find this side length. We had to find this side length right here because we were given one other. We had to find this angle here, and that was it. So we found 3 unknowns, but notice how the triangle is fully solved because we have this side length to be 27.5. We have this side length right here. That one was 12.27. So you have all 3 side lengths, 1, 2, 3, and you have all 3 angles, 1, 2, 3. The triangle is fully solved. Example 4. A hydropole is supported by 2 wires on opposite sides. At the top of the pole, the wires form an angle of 64 degrees. On the ground, the ends of the wire are 18 meters apart. One wire makes a 40-degree angle with the ground. How long are the wires? Okay, so the hydropoles, those are those things that you see on the side of the road, you know, that carry those black wires that birds sit on. That's what a hydropole is. So you have 2 wires on opposite side, and at the top of the pole, so this is like your wire 1, so this is a wire right here, and this is also a wire. And at the top, they make an angle of 64 degrees. So that means right when these 2 wires meet the top of the pole right here, that makes an angle of 64 degrees. On the ground, okay, so if that's the top of the pole, that means down here, this is your ground. So on the ground, the ends of the wire are 18 meters apart. So that means from right here, this vertex, to this vertex right here, this distance is 18 meters. 1 wire makes a 48-degree angle with the ground. How long are the wires? Okay, so at this point, it doesn't specify which one is 48, so you can just choose. Like, let's just choose, 48 is probably halfway of 90, so this kind of visually looks like 48. So, 48 degrees. Okay, 1 wire makes an angle 48 with the ground. How long are the wires? So what we're looking for is this distance right here and here. So instead of me calling it wire, let me just actually give it a variable, okay? So I'll just, so that our notes are complete, like that is your wire and wire. But let's give this length of wire the value x, and let's give this length of wire over here the value y. That looks like a plus, so x, there we go. Okay. So we're looking for x and y in this problem. So how do we go about doing this? Well, you can see that we have a side length, 18 meters right here, and we have an angle that is opposite that side length. Okay, so then you know your brain needs to be thinking, all right, can I approach this using sine law? Well, let's see. Well, ultimately we're looking for this side length right here, and notice how you also have an angle that is opposite the side length we're looking for. So that means that y is your only unknown if we set sine 18 over sine 64. Okay, so this combination right here, this combination that I've just done in red, the angle and its opposite side length, if we set that equal to y over sine 48, okay? This is your only unknown. So you're always like just looking for these patterns, okay? It's just like you're seeing it like, oh, I have an angle and I have an opposite. Can I use sine law? Well, check. If you're able to set up a problem where you only have one unknown, then yeah, of course, you can use sine law. So we're looking for that y. So let's multiply both sides by sine 48 degrees. So these will cancel. So that means you also need to put a sine 48 on this side. So you get sine 48 degrees multiplying 18 divided by sine 64 degrees. And that's going to give you your side length y. So it's just a calculator problem again. So I'll just show this one fully out. So sine 48 equals, so this value right here becomes 0.743. Sorry, that's a 4. And then 18 divided by sine 64. This bracket right here becomes 20.03. And that all is equal to the side length y. So now just take those two and multiply them together. And I get a side length y being 14.87. And because you're dealing with meters, like this was meters right here, this is also meters. So this wire is 14.87 meters. Yeah, it doesn't specify how many decimals. So 18 meters. Okay, so we just need the length of the other wire. Well, we need, in order to do a problem, you need a side length and a known opposite angle. All right, so a lot of these problems are going to follow the same pattern where you're eventually going to have to use the property of a triangle where to get this angle right here, you have to say 180 degrees, take away all your other known angles. So 64 degrees minus 48 degrees. So that would give you 180, take away 64, take away 48. That angle right there is 68 degrees, okay? You needed that because x has to be its only unknown. You need an angle and its known opposite side length. Or sorry, you need a side length and its known opposite angle, or vice versa. So set up what you know. We know we have 18 divided by sine 64. We have to set that equal to what we're looking for, x, and divided by its opposite angle. So sine 68 degrees. So again, you have set it up correctly because this is your only unknown. So now multiply both sides by sine 68. Multiply this side by sine 68. So these cancel. You get sine 68 degrees multiplying 18 divided by sine 64. That all is going to give you the value x, the side length x. So just calculator again, so sine 68, this bracket gives you 0.927, and then 18 being divided by sine 64. This bracket here gives you 20.02, all right, 03 actually, equals x. So now take that, multiply it by 0.927, take those two numbers, multiply them. You get x is 18.56 meters. There we go. So this value right here is 18.56. And that's it. So you found the two wires to be 18.56 meters and 14.87. So I'll see you in class, and we'll do the homework, okay? Bye for now.